Hello, chemists. I'm here to talk about part two of the Unit 5 lab. I'm just going to go through how to get started so you can do this on your own. Um, it's about types of chemical reactions. I strongly suggest that before you do this, you watch one of the videos of the day posted on types of chemical reactions that goes over the 5 types of chemical reactions that this lab is going to discuss. We need to recognize patterns to predict future behavior. That's why we try to put types of reactions or put reactions in categories. So we use these patterns for safety, for political analysis. Chemists try to use classification to predict products of unknown but similar chemical reactions. Down here we have 4 sets of chemical reactions. And hopefully you're going to notice some similarities between the reactions in each set. This set of chemical reactions, this four sets actually, A, B, C, and D, is called a model. And in this type of lab, which is called a POGO, which stands for Process-Oriented Guided Inquiry Learning, models are important. They're sort of the data that you base your predictions and analysis on. Or excuse me, it's the data you analyze to make predictions or come to conclusions. The chemical equations in Model 1 contain the phase notations S, L, G, and AQ. Match each symbol with its meaning. So which one goes with dissolved in water or aqueous? Dissolved in water is aqueous. What abbreviation would that be? And I think you can figure out the rest of them. Based on the examples provided, which set of reactions in Model 1 typically involves ions in solution? Well, which one is going to have an ion? Let's look up here. These probably come apart and make ions. If it's aqueous, they're going to make ions in solution. So this is going to be nitrate, or a nitrate ion. There's going to be a chlorine ion here. So if it's aqueous, it's probably going to make an ion in solution. It's going to dissolve, and we know that dissolving pulls apart crystals into ions. We learned that in Unit 3 lab. So, gases and solids, you can look in group A, B, C, and D for these notations S and G and L here to figure out which reactions involve solids, liquids, and gases. For number 4, match each description to one of the reaction sets. So part of an ionic compound is removed and replaced by a new element. So which group has an ion or a molecule, which is a solid molecule, which is then dissolved in water, pulled apart into ions, and one of those ions is replaced by a new ion. So sort of one partner switches out here. Let's look which one might that be. So it looks like here under set A, we've got iron chloride and zinc, and then we have just iron as a solid, and we have zinc chloride. So that's good evidence that zinc is switching out for chloride. Let's look at this one. So we have aluminum nitrate and calcium, and then we have calcium nitrate and aluminum. So calcium is taking the place of aluminum here. Set A sounds like a good candidate for this first description here. I'll let you figure out the rest of them. This last one you should know. I'll give you a hint from part 2 of the Unit 4 lab. You can use a dictionary or the internet in general to look up what these words mean in real life, and then you can sort of apply them to reactions. Your goal in question 6 here is there are these 4 sets of chemical reactions, and you want to label each set. Which set represents single replacement reactions, which set represents double replacement reactions, which set represents synthesis reactions, and which set represents decomposition reactions. So again, go up here to your 4 sets, C, D, A, and B, and label them with these 4 labels here in question 6. Question 7, 8, 9, and 10, you can look closely at the equations and come to some conclusions here. Question 12 is you can choose an equation and write it in reverse, and then label the reverse reaction with one of the reaction types in Model 1. For example, like synthesis going forward is decomposition going backward. If you're putting it together going from left to right, you're taking it apart going from right to left, or flipping it around. So for 13, which is the last question you need to do, the rest of the lab is extra credit. Each of these equations needs to be identified with one of the types of reactions we talked about: decomposition, single replacement, or double replacement, or synthesis. So that's your mission for Part 2, Unit 5 lab. If you have questions, we'll be having some targeted instruction, or you can always Skype. Thanks so much. This is Miss R. Remember, past question 14 is great to do, but it's extra credit.